So what's the force on that current in this magnetic field? Wait, something's wrong. Down, sorry, this one's down. There we go. It was down on this side, that's the X, and it was up on this side, that's the dot. There we go. What's the direction of the force over here? Down. And on this side? Up. Could you have predicted that? Yeah, it's got to be opposite. We're rotating this loop one way. The force that's generated on that loop has to fight that, right? You don't get something for nothing. You've got to put in energy to get out energy. When you start rotating this loop of wire, a current flows and a force gets set up in the backward direction. We call that a back EMF because you could think of it as almost like a battery set up in the backward direction fighting you. So let me show you that real quickly. Here I have a generator. Hook it up to a light bulb. You can get that light bulb to light up. And you can see well, let me show you my motor too. So I have a generator and I have a motor, or was that my motor and that my generator? Can't remember. They're the same thing as far as we're concerned, right? Let's make this one our generator. I'm going to put in mechanical energy, turning the handle. We're going to get out electrical energy. We're going to put electrical energy into this one, and it's going to be a motor. We're going to get out mechanical energy. Ready? Okay. Now I want to show you the interesting thing about back EMF, because there's a neat application. Let's pretend this light bulb is a battery, right, where we can store energy. Look what happens to our generator when we're not getting any current out. Right? What creates that backward force is the current that starts to flow in the circuit in that magnetic field feels a force in the opposite direction. If I don't hook up my generator to anything, no current flows, no backward force. I can put in a small force. It doesn't take anything to turn this, right? No problem. And it keeps turning by itself. No backward force. I hook up my generator to a battery or a light bulb or anything, and current can now flow. And now when I try to turn this, it's hard to turn. And if I give this a little push, you can see it doesn't go around the way it did before. If I unhook this, it goes around and around, right? If I hook this back up, we get that backward force. So are you seeing a neat application here? You're driving down the street in your hybrid car, and there's no backward force on your generator. It's just rotating. You want to slow down. How do most cars slow down? Brake pads squeeze a drum, and all the energy of moving your car gets converted into heat. Heats up the air around your car, right? Heats up those brake pads. That's how it slows down. Friction, heat. You lose it all. You go to start up again, you don't have any of that energy that you had before. It's gone. It heated up the air. You have to put more energy in to get you going again. So what do you do here? You're driving down the street. You want to slow down. You hook up your generator to a battery. And that slows you down. This generator now is very hard to turn, right? It was very easy to turn before. You hook it up to a battery. Now it's hard to turn. It slows your car down. And while it slows your car down, it's storing that energy in a battery. And you stop, the light turns green, you go to start up, you use the energy from the battery. Now there are always losses, right? You never get all the energy into the battery. You never get all the energy back out. There's losses. But at least you've harnessed a little bit of that energy of motion of your car into the battery when you slow down. So we use that back EMF to our advantage, right? We needed it to slow down. We used that from the generator to slow us down, stored that energy in a battery, and then used that to start up. Okay?